Today's session is actually probably one of the most important sessions, which is deploying your model um, so that everyone can use it, and or whoever has access to it can use it, right? Um, and there are different ways to deploy your models. So let's Mayank, you shared with me a practitioner's guide to ML ops. I was looking at it. Thank you so much for that.
Yep. I shared it in the common channel. It's with the Vertex AI, the
Mm-hmm.
blog post that announced Vertex AI.
Mm-hmm.
It was linked there. I thought this needs a totally separate because it then has the current practices that we need to follow.
Yeah. Okay. And
So from that
continuous
perspective,
monitoring,
yeah.
prediction serving, continuous training. Interesting. Okay. I don't see any code in there, but it seems like a great guide, at least.
Yep, to somebody who is uh, um, mm, uh, new to this part of the workflow or
Mm-hmm.
pipelines or MLOps
Mm-hmm.
can quickly get up to the how do I say the things how they are actually done in the industry and what if we are trying to work in a team, then what are the principles that are expected of you to follow, or what's the lingo that your team will talk to you when you join, or uh, what you can say is
Mm-hmm. Okay.
from that perspective, it's good because I am kind of dabbling in various stuff, so sometimes for me the thing is uh, I kind of forget, or I cannot recall the lingo of a particular area that I'm working with currently. So if I'm dabbling, if I'm a bit with reinforcement learning, that side of uh, stuff uh, 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 totally occupies my mind.
Yeah.
If I'm working with computer vision, then uh, that side of the literature occupies my mind. So
Okay.
if yeah, so
So thank you for sharing. So I want to make sure everyone, were you guys able to run through the entire flow and have the push the model and the serving model here? So you should have like two models. And of course, if we have something set up with AI with the model platform, then this would be pushed to the AI model platform on GCP. Um, so I want to just checking with everyone to see if you were able to run through this practice pipeline.py. I mean, or whatever you have on your end, or from books repository. Um, so, because you should be able to do that even with this error, this graph error, and you should still be able to have this saved model.pb file and the variables and the assets. So, so let me know if you have any questions for those of you who are able to attend today's sessions.
just to practice. pipeline.py file, right?
Yeah, yeah. So you should be able to run through this despite the warnings and errors. As the as we explained, the TensorFlow's or TFX own tutorials has this error as well, and yeah, and you should be able to train your model and output it. So at this point, we should have all the components running successfully. Okay. Anyone else? Anyone wants to say anything? Do you have any questions, or were you able to run through it? Were you not able to run through it? Any thoughts, feedback? All right, I'll take that as you guys have been relatively okay, I guess, on the entire pipeline. So why don't we start with reading? Today's reading will be quite a lot. Hopefully you will be able to at least maybe catch up maybe after the session. And let me look at the schedule a bit as well to see. Okay. Deepai said, yes, I was able to run through the pipeline. Great, Deepai. Thank you for sharing. Okay, so I guess we did not leave any extra sessions for this class. Then we'll just have to run through it. Okay, so today's topic will be on this. Let me model deployment. Chapter 8, model deployment with TensorFlow Serving. Okay, so we're going to spend probably an hour just to read this chapter. If you have not had any experience with model deployment, this will be a bit overwhelming. However, hopefully we will be able to deploy the model on the AI platform. I have not tried Vertex AI yet, but let's try the AI platform first with GCP. And hopefully at this point you have a GCP account. If not, please register one with GCP. And again, it's Google Cloud Platform. And make sure you put down your billing if you have not done so. And it wouldn't cost you more than $1 or $2. I don't expect that even. If you just turn it off, make sure you turn it off, delete everything, so you don't have any model containers running after you do that. So today we'll be trying a little bit on AI platform. So that's that. And also make sure you have, if you want to try Docker, make sure you have your Docker ready, and you can download Docker from Docker's website if you have not done so. So make sure you get Docker from here, okay? All right, on that note, let's get started on the readings. I will not have a timer because Mesh is out today. So we will reconvene in an hour at 10:45 p.m. EST slash 7:45 PST. And then after that, we'll quickly run through the chapter, and then we will just try to deploy the model on GCP and see if we can run it, right? So, all right, let's get started on the reading, and we'll talk to you guys in an hour.
I can start a timer if you want.
Yeah, that's fine. Thank you, Mayank.
So for how long should I set the timer?
1 hour
1 hour.
to till 10:45.
So it's what's your local time there?
The Eastern Standard Time.
Yeah, your local time here. So it's I am setting it up for 60 minutes. Right. Is it fine then?
Yeah, 60 minutes, fine. Just set it 60 minutes. That's easier.
Okay. Okay.
All right.
Hey guys, Venchen, I had a query.
Yes. Did you have a question or something?
Yeah, uh, just a bit. Uh, I'm trying to, uh, I'm trying to get the uh, consumer complaint with narrative file. Oh, where was it, or do I need to construct it?
Sorry, what was the question?
Consumer complaints with narrative. Uh,
Oh, yes. So that's the data sets that you need to download it from. So if you go
yep,
to,
yep. I downloaded the complaints.csv file. And do I need to transform it or something?
no, so this is basically the, one second, let me show you, um, so I'm gonna, quickly share this. So you gotta run this, then it will, this comes from the books,
mm-hmm,
GitHub, and
mm-hmm.
they had a utils, and they had a download dataset.py. So you run this, then you should be able to get this consumer complaints with narrative.csv. Okay.
It's in the folder.
Utils.
Uh,
This one.
utils. Okay, utils.
Yeah, but you just run it. Just clone this GitHub, the books GitHub, and just run Python
Okay,
util.
okay. I'm running the practice examples one. That's the issue.
Yeah.
Okay, okay, cool. Thanks.
Yeah, sure. All right. Time is up. How's everyone doing? So I was trying to deploy the model on the AI platform. However, I keep getting this IAM error for some reasons. On mute. Okay, thank you. So I kept getting some IAM error, which I previously did not get. So maybe they've changed the setting recently, as I have not been working with GCP recently. But I've added these 4 rows, and now I'm trying it again. So, all right. So that's where I am, and hopefully this can run through. And I have a quick prediction script as well. And obviously this is pretty preliminary and just for testing purposes. And on that end, let me jump into the book and the chapter. Oh, so I guess I still not able to run through this. So failed to add IAM policy binding. That might be something new or recent. If anyone is familiar with Google Cloud Platform IAM policy, please let me know.
This is, I think, so with respect to the service account admin role.
Yeah.
Service account admin.
How would you grant the do you know anything about this?
This is the account. I think so. You just have to get this string im.service account admin somewhere in the permission.
Yeah, so I was trying to basically
Enter property name or value in the filters. There's a checkbox here.
yeah, so I was trying to add
Okay.
didn't have this right here. Nope. I don't think.
In the roles, if you click roles,
No, this is just filtering what I already have, rather than adding something extra.
Okay.
Yeah, and this is where you can add another row, but it also service account admin, maybe that's the one.
Yeah.
All right, service account admin. All right, so maybe that would work. So let me recreate this once again. Let me delete this. All right, so I'll walk through this with you guys in a bit, but let me just run through this. V pre-built container, Python version, TensorFlow 2.4, browse that, select, arrow scaling, T4, second, prediction. All right, so I'll let this run while we go through the book. Okay, so now we're getting to the model deployment. This is the final section almost before we orchestrate the entire pipeline. Okay, so there are different ways to deploy your model, and you could try to create an API endpoint, which is what we're trying to do with the AI platform from Google. And also you could just develop a Python Flask app and host it on a server. Okay. And so there are different ways to deploy your model, or you could package your model and literally deploy on PyPy, right? So PyPy package. So you could literally just deploy your model as a package,
Yep.
and so that everyone can basically call your or just pip install your package as or model as a package, right? So that's that. Um, and as you can see, this is kind of a way to develop a Flask endpoint for your model prediction. And we will get to a little bit of this when we try to basically develop a REST API for serving scikit-learn models. Okay, but there is downside of model deployment with Python-based APIs. And I think the author makes very good points, even though I think this is something that people do a lot, even in corporations. But that's why, we're trying to basically standardize the ML ops workflow and making sure, everything is kind of incorporated into the workflow. And also, with this, it's basically there are different weaknesses, such as lack of code separation. Within a corporation, you could have two different teams. One could be API team, and one could be your data science team, or model development team, or bunch of research scientists could be developing the model, but they might not touch the API, and there might be a specific data ops or API team helping you to serve your model. Then you actually want
Uh,
to.
Query, in the example 8.1 is not in the project, right? I didn't find the particular file. I was kind of skimming through it.
Yeah,
Or
correct. I don't think this script
the
is.
Flask and endpoint, yeah.
Yeah, yeah, exactly. This pretty simple, fairly simple one. Yeah, no, I don't think it was in the books repo. At least I was able to find it. But so continuing what I was talking about, basically, and sometimes you don't want to have your API written in the same language as your model or your data science components, right? Because sometimes you just want your API um, uh, to be written in a faster language than Python. That could totally be possible within a bigger company. So there is, a lack of code separation when you try to serve your model in this way. Okay, even
But
though that
but
is quite
why?
common. Yeah.
But why? If everything is in Python, then why would you deploy or make pipelines which are in a faster language, like in suppose Java or C++, when
Yeah.
it's
So
too easy to uh, get it done via this way.
Well,
And there are
yeah.
accelerators too with respect to, if you go to open MPI and that stuff, in which if you want to parallelize it, and
Mm-hmm.
if you want to have that low latency end-to-end endpoints, then those iterations can be done in the same language if we have our proper optimization loops. Uh,
Mm-hmm.
I mean, so uh, uh,
Yeah, so one case that could be for which for separating or having a different language for API is, for a bigger corporation or for a bigger even product, you might have APIs for a lot of services, not just for ML service, and then you might have a entire API gateway for all the APIs that you might have, so that itself might be written in another language. That I think that's totally possible. Um,
yep, yep.
yeah. So,
I agree. Then the endpoints might vary based on the type of application that you're trying to serve,
mhm,
or the type of component that you're trying to hit.
correct. Yes, absolutely. And the other thing is lack of model version control. So the book talks about it doesn't make any provision for different model versions, and so on and so forth. So as you can see, when you run through this pipeline, you should have a timestamp that's attached to the served model. In my case, it's 1622. There's 78540. That's the model version typically, and I believe that's the Unix timestamp. Correct me if I'm wrong, but I think that's the case. And this is something that you can use to version model. And of course, you might want to do it differently, but that's how I do it. And I think it's fine. And that's something you could just push to your cloud storage for model storage purposes. So
Mhm.
um, so cloud storage is where you actually store the models. And this is similar to AWS S3 buckets.
Mhm.
Yes. So when you, then what I did was basically uploading this folder, right? So serving model and consumer complaint pipeline, and uploading that. And if you run through another time of this pipeline, it would basically keep creating another version and another version and another version of the model. And you can just upload the entire folder to this. Or I think there is a way to basically directly push this your model to the cloud storage bucket, which I have not been able to implement yet. I haven't had time, unfortunately, this week. Been quite busy, but I manually uploaded this to the Google Cloud Storage. And if you click into it, that's where the model is, right? Um, and again, basically, if you run through different versions, it will just basically stack up under your bucket for different versions.
Mhm. You know,
Okay.
I had reached to, I think so. I was trying in the pipeline underscore root. I was trying to, if you go back to the folder structure that you had locally,
Oh, yes.
uh, yeah, the serving model. Okay. I will have to generate it. Okay, okay. I was, I'm still, I have to catch up. So, how will you recommend I go on from? Will I have to generate this serving underscore model, or it's in the code?
Yeah, so this was already incorporated. If you look into the pipeline,
Mhm.
this was defined as the serving model directory right here in the
Okay.
config.
Yep.
Okay, and this is where you pass in as the parameter for init components.
Okay. Okay. Yep.
Yeah,
Yep. Yep.
yeah.
Oh, yeah. I had here an error with the Boolean, I suppose.
Okay.
Uh, we I wasn't able to find a data splits filtering or something like that. Okay, I think so. You resolved it with respect to uh, you had to run transform and remove all those bools with I think so zero or something. Uh,
Mm-hmm. Mm-hmm.
uh,
Okay. Yes.
yep, yep. I will correct this. I had a
Okay.
problem with the modules with the zip code where it was 0000. Uh, the error that you resolved last time, last time. I, I
Okay. Okay. All right. And I think the book is run. By the way, the book. I think the book code is run on this. So I had to correct this. The book's eval config might be wrong. The threshold has to be set within this. With each metric, this seems to have caused the model not to be blessed. So initially, I was not able to bless the model. Um, and if you look into the the book's code, this is a side note. So and this goes back to model analysis and validation. Mm, yeah, so you see, it was separating um, the uh, configurations. One second, it was separating the metrics and thresholds. Whereas what I'm doing is, so let me. So it was separating the binary accuracy here and the thresholds here. Um, however, what I've found out is that from Tensor TFX official tutorial, it seems like the class name and threshold need to be all together within one tfma.metric config. And with that, I was able to bless the model. So just so you know, this might be wrong. Um,
okay.
yeah. All right. So let's go back to chapter 8. All right. So lack of model version control, we talked about that a little bit. And I was trying data version control as well. It seems to be fun in to incorporate as well. And it's a cool thing with DVC, and I tried a little bit of that. So if you guys are not familiar with data version control, you can check out dvc.org. dvc.org. Okay, this is something that I've started using for my work, basically trying to version the data, not only the models, but also the data sets as well. And this is basically Git for data. Okay, and it uses Git on the back end anyway. Um, and and you can basically version the data sets and push the versions to something like AWS S3 buckets. And you can pull different versions of data as well. So it's a pretty cool tool to incorporate into your, I guess, your ML ops workflow as well.
Yep. And it must use get large type of operation to upload and download data sets,
Mm-hmm. Mm-hmm.
because the size must be, I think there is a specific get large file storage that get LFS.
Yeah.
Maybe. Yeah.
Yeah. So so yeah, this is something, open source version control system for machine learning projects, right? So this is great for machine learning projects as well, as we, have to iterate our data sets as well. So, all right, um, that's data version control. Inefficient model inference. Um, so yes, so basically for Flask, um, if you have a Flask setup, Uh, this means each request is pre-processed and inferred individually. The key reason why we argue that why a setup is only for demonstration purposes is that it's highly inefficient. During the training of your model, you probably use a batching technique, first of all. And also, a model server can gather all requests during an acceptable time frame or until the batch is full and ask the model for its prediction. This is especially effective method when the inference runs on GPUs. So, and this is why you try to not deploy models with Flask, but on these specific, ML platforms where
Mhm.
you can serve your models in, pre-built containers or customized containers. As we were already seeing, I was trying to configure that, even though I still was not able to run through this for some reasons. It was totally fine
Yes.
a couple months ago when I ran through this, but seems like now I'm having trouble. Okay. And after adding the service count animating, I'm still having trouble with this. So, all right. I'll figure it out later on and update you guys on that. All right. Um, TensorFlow serving. Um, Basically, TensorFlow serving is an architecture that allows you to serve your models, right? Now, that you might be asking, hey, then what is AI platform using? Well, it's actually using TensorFlow serving within a container to serve your TensorFlow model. Okay, so in case you have that question or you weren't sure what's going on, that's the case. Okay, it's just that's why it's called pre-built containers. They already have TensorFlow serving within that container, and it basically has that same Docker run or Docker pull TensorFlow serving within the container. Okay, so and this is kind of the overview of the TensorFlow serving architecture. Okay, and it has the client here, servable handler, model manager with version policies, model loader, model source, TensorFlow serving. And And so for a typical, Keras model or TF.Keras model, you can just say, hey, model.save, and specify a file path. Then you can save that model, right? But of course, in TFX, we have, well, let me see what we have within module.py. Run fm, model.fit. Yes, we have that as well. Okay, model.save. So it's just right now this is a one line code. Okay, but within the run fn, which is called by tfx trainer component, we have that here. Okay, and we have the model signature here, and we have the model.fit here, and we have the callbacks for TensorBoard. Okay, if we want to load it up TensorBoard, we could, and we talked about it last time. Okay, so that's how we save models and export models to a path. And we have your serving. Yes, so we have the serving model directory, right, which we specified here as the serving model directory, which is underneath the pipeline root. This is our pipeline root. It's great because it's being ignored. That's why it's gray. But it's under, again, it's under serving model. Okay, this is the directory for where we served model.
Yep. Here, the last time that we talked about the run fn method, the tfx trainer. Could you give a reference to that again? How will it be called?
Yes, so this is being called underneath the TFX trainer component. And as you
Oh,
can
I
see,
see.
we have a bunch of training quarks.
Mhm.
And under the training quarks, the module file, this is where we pass in the module file, and it will automatically scan for the run_fn function.
Mhm.
Okay, great.
Yeah.
All right. So, and as you can see, you can specify a timestamp to your exported path. Okay, and you can do whatever you want, right? In this case, the author used integer and time.time, and that's I believe that's the Unix time format. And you just basically, stream format that, and you model save that as a file path. And it obviously it made a mistake here. This should have an underscore here, and I don't know if it was a misprint or a mistake on the author's end, but and you can choose your save format, TF, or I believe there are a couple formats as well. Let's check what kind of formats we have. TensorFlow model format.
I think so. There must be the the what do we call two more but X.
Say it again.
There are two more common formats. One is the
Okay.
10,
Yeah.
10. Yeah.
Yeah. So it seems like there is a saved model format. There's TF1 hub format, TF.js, TF Lite. I guess saved model is something that I'm quite familiar with. That's something that we always use. And it's the recommended format for sharing TensorFlow models. Um, and TF Hub formats is something that hey, if you happen to create a really great model and TensorFlow adopts your model into the TF Hub library, then you have that under, I guess, TF1 Hub formats. And
Yeah.
also you have TF Lite formats that's used for on-device inference.
Mhm.
Okay, which is I guess can be adopted by edge devices. If you have IoT devices that you would like to do prediction services on device, right? Not on the server, but on device. And this is called edge, right? And you would want to use something that's called TF Lite format. And basically, your model would be way much smaller as well. And TFJS, that's in browser ML, right? So if you want to do ML services or operations on the server, then rather than on the on the browser rather than on the server, then you do TF.js. Okay, so and we okay, this and for TensorFlow estimator models, you need to first declare a receiver. And I think a lot of the models are categorized as estimator model. And as you can see, this is kind of the file structure of exported models or saved models. Okay. And you have a saved model.pb, the binary protocol buffer file contains the exported model graph structure as a metagraph def object, and you have variables. This folder contains the binary. Let's look into this. This folder contains the binary files with the exported variable values and the checkpoints corresponding to the exported model graph. So those are the binary files, and apparently it's pretty big. It has 1 gigabyte.
1 gigabytes.
Yep. And you have an assets folder. This folder is created when additional files are needed to load the exported model. Okay. The additional files can include vocabularies. Okay. And model signatures. Model signature basically identifies the model graph's inputs and outputs, as well as the method of the graph signature. And we specified model signature within the module.py right here. So, and under run_fn function as well. And this is the model signature. Okay. And basically, these mappings of model signatures are useful if we want to update the model without changing the requests to the model server. So it creates kind of a mapping, right? And identifies model graphs, inputs and outputs, right?
These signature work by default, or do we have to?
Say that again?
Will this signature work by default? Or
Yeah,
do we?
yeah, it does. So we do have so it works by default as well.
Cool.
So yeah.
Because here I think so. Yeah, in the export saved model, they had some different parameters.
Yeah.
Because I haven't um, um, run this yet, so I was thinking.
Mm-hmm. Mm-hmm. And so there are different signature methods. One is predict method. This one is called classify method. This method expects one input with the same inputs and provides two input output tensors, classes, and scores. So it's basically sort of a definition or configuration file for your model, basically. All right. So, and you can inspect your exported models and by doing safe model CLI show. And you can check the signatures as well. I'm not going to dig too much into that. And you can test the model again with saved model CLI. Okay. All right. So I asked you guys to get your Docker. Hopefully you guys have already had that. And let's try it with Docker poll and some Docker runs.
And plus, there was a Docker summit also going.
Yes, I saw that.
it will be from today or?
Yes. So if you guys can open up your Docker desktop and start trying some simple Docker commands, that'd be great. Just so you can get a feel and and be more hands-on if you are not or haven't had too much experience with Docker. Okay, so normally Docker takes a little bit of time to load up, depending on your machine. So my machine is, I'm still running on the 2017 machine, unfortunately, because, and I have had a rough time trying to run the M1 Big Sur, and I could tell you all the stories about it. But it has been a rough week on trying to configure everything
So
for.
how is it running now?
Oh my
With
God!
that M1.
Yeah. The conclusion is if you're if you don't want to try to configure everything and debug everything, I would try to delay your purchase of the M1 chip. I mean, it's even though it's better than I would say half a year ago. Half a year ago was probably a mess, and now everyone is getting more adaptive and building different packages. So basically, let me tell you one thing: a lot of your packages wouldn't be able to. A lot of the packages you wouldn't be able to run or install with pip install
Hmm.
on M1 with Big Sur. Okay, period. And you would have to, run different commands, and I can show you some of this stuff. Let me just show. Um, oops. Sacrificed. All right, so I have. Here's my Big Sur M1. So I already debugged a lot of stuff. So you can't even install NumPy with M1 chip.
Oh.
Apparently, and Pandas too. You can't just pip install with that. You have to run, brew install something, and so a workaround. Basically, you need to work around things, and you use Homebrew and replace Mac OS Blast by Open Blast for pip install and all that stuff. And you would have pyinf build error. You would have a bunch of package build error. Okay, so the bottom line is, try if you don't want to go through all that stuff. It is fast. Let me tell you that. It is fast. It is great. It's I basically I got a 1 terabyte built with 16 gigabytes of memory and 8 gigabyte. I think it's 8 core CPU, 8 core GPU, and so everything is great, but it's not Intel chip. It's ARM M1 chip. So a lot of your packages, your beloved Python packages, are not compilable under that. So you will need to find a different way around with ARM M1 chip. So yes, so that's the nutshell of my past week of experience of struggling with M1 Big Sur. So
Cool. So you have totally switched out. You're still working on your older.
well, as you can see, I'm still running on this 2017 machine, so not totally yet, but I'm getting my way through. So slowly, because I have to figure out how to debug all these errors on some of the projects. And if I cannot do it on time, then I have to switch to the old machine, right? And which is the case right now. And even Python, even some of the Python stuff, you would like, basically like this case, so I was only able to install Python 3.7.9 on Big Sur M1 because 3.8 does not have the right arch target yet with PyInf. So PyInf is, with 3.8, that's off the table. So I was only able to do 3.7.9. So a bunch of these things you would have to go through. Okay.
Oh, damn.
Yeah.
Thanks for the heads up, man.
Yeah. It was a lot of excitement when I got the machine, obviously, but
Yeah.
not so fast. Yeah.
No. Yep. It's understandable too. It's quite new, and the ARM targets are, uh, yeah,
Exactly.
they.
Exactly. So okay. So now we got Docker running. And now we can do Docker version. Okay, so I have Docker 20.10.5. If you have Docker running, it should say Docker is running. And you could restart it, you could quit it, and you have a dashboard. Okay. And you have, you can check your containers here, and you have your images here. I have image called DSS scraper. That's something for work. But and you have your settings here. Okay. And something you want to check is your resources. So I actually pushed my resources, try to, always try to be higher in terms of disk image size, because sometimes some of the containers and the memory higher as well. Some of the containers I have are quite big, so you want to make sure you have you are able to compile these containers images and also push them, right? So make sure if you're getting memory error or image size error, then that's where you basically configure higher image size or memory. Um, okay, and of course you can basically check your Docker version here, and you could do Docker container ls. I typically do -a. That means I can have all the containers that are running, or all the containers that are have been stopped. So it's this is a flag that's called -a. It stands for all. Now again, so I have a stopped container, but if I run Docker container ls, it wouldn't have anything because that container has already been stopped. Okay, and the other command that you will typically need is Docker image ls. Again, I have an image right here. Okay, and I have a stopped container. Okay, and what you want to typically do is, let's say if you have a build error, you want to do a command that's pretty handy. It's called Docker system prune -af.
Okay,
And
delete the.
yes, so now if you check my image, I don't have any images anymore. So if I check my container, nothing. Okay, so this is a way to clear out all your caches and also all your stopped containers and unused Docker images as well. So that is a pretty handy Docker command. All right, so now what we can do is we can pull this image called TensorFlow Serving. Where are we pulling it from? This is directly from Docker Hub. And let's Google this. or search this on hub.docker.com. And this is the image that we are pulling from. It's called TensorFlow Serving image and has had 10 million pulls from people. Okay, and if we don't specify the tags, that means it's just the latest tag. Okay, and if you have a GPU and you want to serve your TensorFlow model on a GPU, you need to pull latest GPU. So specify that tag. Okay, so what you want to do is Docker pull. Let me go back to the book. Docker pull. Let's do this. So now what it says is, hey, you don't have this image locally. Now we need to pull the entire image from Docker Hub. And it is quite a big image with 2 gigabytes, 500 megabytes. I don't know if I have enough space for this. I hope I do. I still have 4 gigabytes. Okay. I'm running on a 128 gigabyte machine, so I have to be cognizant of that. And what you want to do is you want to monitor your memory and your available space, right? And this is a great software. It's called Clean My Mac, and I typically use that to monitor my memory, which has 16 gigabytes, and my storage space. So now, as you can see, it's dropping, right? And it's dropping fast because I'm pulling a big image, and I only have 280 megabytes left.
That that would be a huge issue, man.
Because I
Try
am,
this.
yeah, go ahead.
Yeah, I'm saying you should stop this, or if you can, uh, or if you can delete some more to get the space.
Yeah, the space should be enough. I think
Okay.
we're getting close, but the space should be enough. And now, if you want to have native Ubuntu installation, you can go through this. I'm not going to go through that right now, but this is how you pull a Docker image, okay? And then you can run it right away with that image. So you're basically running the image that you just pulled. Okay, so I actually pulled the GPU image, which I don't have a GPU. So I should have probably pulled the TensorFlow/Serving.
Mm-hmm. And, it's fine. It will automatically fall to the CPU, the device.
Okay.
Yep. And
All right.
that's a heads up. I have tried, and yeah, I've experimented with the TensorFlow and built it from scratch using Bazel on my Ubuntu machine that I'm using. Uh,
Yeah.
it's it's it runs perfectly because the instructions that the AMD instructions that I have uh,
Yeah.
currently the pull that I'm doing from the Docker does not utilize that, but we can have that built instructions there to utilize whatever your Intel or AMD CPUs instruction set, and yeah, that will make it a few times faster than the original or the default pip installation or the Docker installation that you get.
Yeah. Yeah. So I actually did run out of space. I apologize for that. I should have pulled the smaller image, and this is probably smaller TensorFlow serving. So, but and we are kind of on time already, 11:37. So why don't we do this? We're gonna stop right now, and continue this session next week, because it is a fairly important session. And I want to be able to cover, how you can deploy your model on the AI platform as well, make it a hands-on experience. And I want to debug this as well. I'm sure I can debug this and make sure I can, predict based on the model deployed. And we can continue on the journey of Docker a little bit with some of the Docker commands in the book. Okay, so I'm gonna extend out the schedule, 1 week going forward. So next week we will still be talking about model deployment with TensorFlow Serving, as I would love to cover an extra session on this, since this is actually very, very important, and it's probably one of the most important sessions in this class. Okay, so, but before we close off, any questions on this?
Yeah, Wenchan, I just had a related question.
Yeah.
Just trying to get I'm just playing catch up and trying to get the practice pipeline to work.
Yeah.
And I'm running into like a CUDA out of memory error when I try to run it. Do you have any idea? Yeah, I'm getting CUDA out of memory coming up when I try to run the pipeline.
Are you using GPUs?
Yeah, I have a GPU running. Should I just set it to CPU, or what's the best way?
Yeah, so I've not been able to test it on a GPU. I've just been testing it on my CPU machine.
Oh, okay. Gotcha.
Yeah, so maybe just run it on this CPU, but that error probably means your GPU memory ran out.
Yeah, exactly.
So you just need to reduce the batch size.
Okay, yeah.
Hopefully everything will work fine.
Okay, thanks.
Great, awesome. Thank you for that, Mayank. Great. Any other questions before we close off? Is everything okay?
No, great session.
Great.
Yeah.
Awesome.
Yeah, thanks.
Thank you. Thank you, guys. All right, have a great night. Let's talk next week. Hopefully everyone can have a great Memorial Day weekend, long weekend as well, if you're in the United States and celebrate that holiday. All right, have a good night. We'll see you next Wednesday. Bye-bye.
Thanks.
Yep.
All right, take care. But I have some errors that we might meet in a weekday.
Yeah, you can ping me on Slack if you have any errors, or just send it on into the channel if you want.
Cool.
Yeah. All right. Thank you. Bye-bye.